Welcome back to Transcended Institute. In this tutorial, we are going to talk about functions. So, if you want to understand the relations and mapping, the domain, how to find the domain of the rational function, how to sketch the piecewise function, and of course, a lot of things under functions. Let's begin our discussion with relations and mapping. So, the first question that I have is let A be equal to 0, 1, 2, 3, and B be equal to negative 2, neg 1, 0, 1, 2. Which of the following set are ordered pairs represent the function from A to B, and for each pair state the domain and the range. Then after that, they are saying that you can represent the ordered pair in form of arrow diagram to see the picture. Now, one thing I want you guys to understand from here is that when we're talking about the domain, we're talking about the x values. So x is the domain, and the y values, this is now what? The range. Okay, so another thing that I want you to understand is that I'm going to have x, I'm going to have y. The first thing that comes first, this is x, this is x, this is x, this is also x. The remaining ones are y. We do know that the coordinate is x comma y. Okay, so meaning that the domain in this case, for the first one, if I want to find the domain, I'm going to say it's 0, 1, 2, 3. What of the range? The range, these are y values. So the range is going to be, we're starting with the lowest number, that is negative 2, then 0, 1, 2. That's my range. Now I'm going to represent this in an arrow diagram. So I have got in x, I have got 0, that is my domain. I have got 0, 1, 2, 3. So this is my x, my domain. The y, I have got negative 2, 0, 1, 2. That is my what? That is my y. Now let us look at this. We have been told that we should use arrow diagrams. We can clearly see that 0 goes with what? 0 goes with 1. So I'll say 0 from x, then it goes to what? Y. Okay. 1 goes to negative 2, 1 goes to negative 2. Then 2 goes to 0, 2 goes to 0, and 3 goes to 2, 3 goes to 2. Now from here, let me explain. How do you know that this is a function or not? For every input must have what? Must have an output. What I mean is, perhaps you have come across any equation where you are finding two values of x, let's say maybe plus or minus 2. These are the answers. Maybe the equation is y is equal to, let's say, x squared minus 4. Okay, then you equate y equal to 0. Now x, you can have two values of x going to one value of y. That is okay, but not the vice versa. So for every input must have an output. So in short, what I'm trying to tell you is that for every member of y must be at least mapped to a member of what? X. Then that is a function. Okay, so this is the first case, and I can clearly see that this function is one-to-one because one value of x goes to only one value of y. So then this is one-to-one function. So you are going to see the different kind of questions that we are going to come across. For example, part B, part 2. Let's see part 2. We see if that is a function. So I believe at this point you can now list the domain. So what I'm going to do is, the x values, I have got 0, 2, 1, 3, 1. So I've got 0. Okay, what else do I have? 1, 2, 3. That is my x value. At the same time, that is my domain. So you represent the domain the way I presented the first one. The y value, we start with -2, -1. So we have -2, -1. What else? Then I have, do I have 1? Yes, I have 1, then 2. So I have 1, then 2. So that is my what? My y, my range. So this is my x, this is my y. At the same time, the domain is 0, 1, 2, 3. The range is -2, 1, -1, 1, 2. Okay? Now let us map. We see if this is a function or not. So 0 to -1, 0 goes to -1. 0 will go to -1. What else? 2 goes to 2. 2 goes to 2. Then 1 goes to, I have got also 0. I've forgotten 0 on range. So there should be 0, then there's 1 here. There's a 0 here on 3. 1 goes to what? 1 goes to -2. And the 3 goes to 0. At the same time, 1 goes to 1 as well. Okay, so 1 goes to 1. This is what I was telling you. Before I explain if this is a function or not, let's first do this. So I'm going to simplify this thing in this manner. So let's do this. Whenever we are talking about x value, think of what? Think of a wife. Whenever we're talking about the y value, think of a man. So let me say, think of, this is a lady. Then think of this is what? A man. It is okay for a man to marry more than one wife. That is perfect cool. So one man can have more than one wife. So meaning that if I have got if I've got one more than one value of x going to y. For example, let's say I have got a, b, c going to just d. That is fine, because one man can marry two ladies or can marry three ladies, but not the vice versa. Okay, one lady cannot get married to more than one man. That is a taboo. It's not possible. Okay, so that is, you need to remember this. This is the relationship which is there between x and y. So like if I see here, this x1 is going to more than one value, so it maps into this and also into 1. It's not possible. One lady cannot get married to two men. So this is not a function. It's not a function. But if this was the opposite, two values of x going to one value of y is fine. That is a function. Okay, so this is not a function. Okay, so I'll now go to what? To part 3. So part 3, if I can see the domain, you list the domain like the way I listed on part 1. So domain, I have got 0. What other numbers do I have? I have got 1. What other numbers do I have? 2, 3. That's my domain. So I'll list there to say my domain. I do this 0, 1, 2, 3. That's my domain. Then I also have the range starts with also 0. So I've got 0. Let's see, what other things do I have? I have 0. Yeah, I only have 0, 0, 0, 0, 0, 0. So I'll put this 0 in between. So this is x, this is y. Let's now map. So 0 goes to 0, 1 goes to 0, 2 goes to 0, 3 goes to 0. Yes, it's fine. So this is x. I've swapped this y. This is x, this is y. It's alright. So 4 ladies are getting married to 1 man. That is cool. So more than one different values of x can go to only one value of y, but not the opposite. Now I'm going to leave part 4 for you. You do it for me and then post the answer in the comment section. Another thing that I want you to understand is that if at all I have got a, b, c, d, e, f, so this is the domain and this is the range. So if at all I have got a scenario where this is mapped into that, okay, and this is mapped into that, and also this is mapped into here, then if all the elements of x are mapped but some members of y are not mapped to anything, that is not a function. But the opposite is true. What do I mean? If I come across any function that is like this, a, b, c, d, e, f, g. Let's now look at this. If this is my x, this is my y. This one goes there, this one goes here, and then this one okay, this one goes here, and the focus should just be on y. Okay, so if all the members of y are mapped to at least something from x, then that's okay. Even if the x guy is not mapped to anything to y, that is okay. So this is a function. I'll conclude that this is a function. There is no debate about that. That is a function. It is possible I can have x value, but this x value is not going to be part of the solution to y. It's fine. Now, based on this information that I've given you guys, try to solve part 4. Try to solve this question and send the answer in the description. Tell me what the domain is, tell me what the range is, and also try to map, is this a function or not? Give a reason for your answer. I'll be waiting for your answer. Let's now look at question 2 and 3, which is saying which of the following equation defines y as a function. So this question is related to the one we are from doing for domain and range, for relation and mapping. What do I mean they're related? The moment if you want to define anything as a function, then y has to be alone. Y should not be raised to anything, because if I have, let's say, y being equal to x minus 4, or I can say x squared minus 4, it's possible I can have more than one value of x going to only one value of what? Y. That's what we said, and not the opposite. So if I come across y squared is equal to x minus 4 like this, then this is not a function, because it is telling me that two values of y, they are mapping to one value of x. That is not true. Okay, this means that two guys or one lady is getting married to how many guys? 2, which is not true. So this is not a function. So for you to define something as a function, y has to be alone. Y should never be raised to anything. Based on this information, I believe that you can answer these questions now. So number 1, y is alone. So this one defines y as a function. This one, if I make y as a subunit formula, what I mean is I shift 5, it will be y squared is equal to x minus 5. This one, now it is telling me that two values of y mapping into what? Or one value of y mapping into two values of, or one value of x mapping to two values of what? Y, which is not true. So this does not define y as a function. No. This is true because y is alone. And this, we know that this is a radical function. So y is alone is not raised to anything, it defines y as a function. Y is alone is not raised to anything, it defines y as a function. What of this one? If I make y as a subject of formula, it will be 3x, it will be 36. Okay, or let me just shift. What I will do is this: it's x squared minus y squared is equal to 36. So I'll shift y to the other side. So I'll have x squared minus 36 is equal to y squared. As long as y it is squared or raised to a power 3 or to the power 4, that does not define y as a function, because I cannot have two values of y mapping to one value of x. Even if x is raised to the power 2, still this is not a function. Okay, it's not a function. So this is how you know that this is the function, or y defines the function, or the equation defines the function, knowing that y should be alone and y should not raise to power 2 or to power 3. Okay, now let us talk about question 3. So before we go to question 3, I'm going to give you this. What if I'll give you this homework, an assignment: x minus 2 being equal to y, and y squared being equal to x to the power 3 minus 4. So I'll say this is question 1, and this is, oh no, I'll say this is 6, then this is 7. So I want you guys to go ahead and tell me if this is, defines y as a function, and if this defines y as a function. Let's go. Type the answer in the comment section. We see. Let's now go to question 3. So what is question 3 telling us? Given that f of x is equal to x to the power 2 minus 4x plus 2, find f of 5. You know, this is something that is not difficult. When you say find f of 5, where there is x, put 5. So 5 squared minus 4, 5, then plus 2. 5 squared is 25. 4 times 5 is 20, plus 2. 25 minus 20 is 5. 5 plus 2 is 7. Done. Do the same for part 2. Put where there is x, put negative 3, find the answer. Okay? So I'm going to do part 3. F of a, where there is x, put a. So it is a squared minus 4a plus 2. It's done like that. So the answer is a squared minus 4a. Yes, quite okay. You are wondering why these things look to be simple. They are simple, yes. You just plug in the values. If we can look at this other question here, which is telling us part 4. F of a plus b, where there is x, put a plus b. Now since it is squared, I have to square it. Minus 4 a plus b, then plus 2. Now expand this. So expanding that is a squared plus, in case you are wondering how I'm expanding this, a plus b, this is also a plus b. So we are expanding now. I'm multiplying a by b. So a times a is a squared, a times b is ab, then the other one is going to be also ab, then the other one b squared, minus this one will be 4a plus 4b plus 2, like that. So 4 squared, I'll bring this b squared here, these two can be added, and that is going to give me 2ab minus 4a plus. Why is this plus? It should not be plus, it should be minus, because this negative is going to affect everything inside. So this has to be minus. Minus 4b plus 2. And this is my answer. It's not something that is complicated. So for part 5, you can clearly see it's just to, the first one, we need to put a. So they say for the first one we are going to say we put a. So if I put a, it's going to be a squared minus 4a plus 2 plus, you get my point, right? The second one I need to put b. So what you can do is you can first do this. You can first also find f of b. F of b is b squared minus 4a minus or plus 2 minus 4b. So you are adding this and that. So the final answer will be a squared minus 4a plus 2, then plus again b squared minus 4b plus 2. But these two can be added. It's going to give me 4. So it is a squared plus b squared minus 4a minus 4b then plus 4. That becomes my final answer. Nothing is complicated here. Maybe but the last one. So the last one is the same thing. Where there is x, they will just want you where there is x, you put x plus h for the first part. So we'll say where there is x, I'll put x plus h, but it has to be squared. So if we go to calculus, that is the formula for first principle. Okay, so minus 4x, where there is x, now we replace what for the first part. So what I mean here is that f represent everything here. So where there is x, again I'll put x plus h, then plus 2. Again minus again f of x. F of x is just basically the original x. So I'll put them in brackets. X squared minus 4x plus 2. I'll divide this by h. Now we expand this. Expanding this, if you expand that one, you should be able to get x squared plus 2xh plus h squared. Then this is going to be 4x minus 4h plus 2. Now let's distribute negative. So it will be negative x squared minus minus what? Minus, so it's going to be plus now. Negative and negative plus 4. Okay, then minus 2. Like that. Everything divided by what? By h. I want you to understand one thing. This 4x and this 4, where is it? Here I'm supposed to include is 4x, yes. So this 4x and this 4x can cancel. It's 0. This 2 and this 2 can cancel. It's also 0. Then x squared and x squared can also go. What else do we have? The thing that we have remained with on top is 2xh plus h squared, then minus 4h divided by h. These are the things I've remained with. Now, I'm not going to end here because the first part I can clearly say that there is h everywhere. So I can factor out h on top. I can factor out h on top and say h open brackets x h x, so h has gone. So I will remain with 2, sorry. Here I need to remain with 2x plus h minus 4. Then here there is h. Now I can cancel this h. And my final answer will be 2x plus h minus 4. That's the final answer. So there's no debate about that. But at the same time, if I want to differentiate this using the first principle, I would have gotten the answer to be 2x minus 4. In that case, h goes to 0. But forget about that, we'll come back later. Okay, so that is it for question 3. Let's dive into piecewise function. Now, let us try to know how to sketch or to draw the graph of piecewise function. So piecewise function is something that is very simple because the conditions, you're going to be given the conditions. You just follow what you have been given. Remember, the main issue is to know the x values. If you know the x values, then you're home and dry. For example, let's start with the first one. If I look at the first one, f of x, piecewise function, so we have got two functions here. Another function is telling that x is equal to 4, and for x should be greater than or equal to 0. Another one is telling us that f of x is negative 4, and for x should only be less than 0. Okay, so a piecewise function is a function, it's a type of a function that has got more than one function. So for example, here I've got two functions. The second question, I've got three functions. Okay, now these functions has to be on one graph, but how do we go about it? Here is the deal, guys. The first thing, I need to come up with the coordinate for the first function. I'll say this is y, this is x, x, y. So I'm going to choose, let me just do 3. They're telling me that x, for the first one, x has to be greater than or equal to 0. Starting from 0, I'll go 0, 1, 2, 3. So there is no x value here. It is telling me that for any value of x that I'm going to plug in, the answer should be 4. That's what it tells me. Then the second one, since I've said that we have got two functions, the second one is telling me that x should be less than 0. Starting from 0, but 0 is not included. So less than, I'll start with negative numbers. So since 0 is going to be the highest number, I'll write 0 here. Then I'll write negative 1, negative 2, negative 3. What does it tell me? Any number I'm going to plug in, as long as that number is less than 0, the answer is negative 4. So everything will be negative 4, negative 4, negative 4, negative 4. When I do this, let's now sketch. You're going to see how this graph is going to come out. It's going to come out very perfect. Okay, so I can clearly see that in x values, the highest number I have is 0, 1, 2, 3, 4 in positive side. So 1, 2, 3. I end there. In y, I have got negative 1, negative 2, negative 3. So negative 3, negative 2, negative 1, 1, 2, 3. And then in x, if I go here, I have got what? 4 in y. Even here I've got negative 4. What does it tell me? It tells me that the first graph is going to start from 0, 4 is here. But at that point, is it included? Since it is greater than or equal to, it tells me that it is included. Okay? Then 1, 4 is here, 2, 4 is there, 3, 4. So it keep on going. So starting from this point, including everything here, put an arrow because I do not know where it is ending. So this is my f of x being equal to 4. Then the other one, since it is x less than 0, at that point is not included. So the first point, that is 0, negative 4, is not included. This point is not included. So if it is not included, put an open circle. So you put an open, not included, put a closed one, included. Okay, so this one, then now negative 1, 4 is here, negative 2, 4. So this one keep on going this side as well. So this is going in this direction. Then put an arrow. This arrow tells me that I do not know where the graph is going. Okay, so the sketch that I've given you, the graph that I've given you, is for this piecewise function. So that's what it means when we're talking about piecewise function. It's not something that is complicated, but if you just try to understand these simple principles, it's going to be easy for you. Now let's dive into part 2. Okay, we dive into part 2. So try to explore different type of questions under piecewise function and try to see if at all you can manage to solve. Okay, so we have g of, in this case we have got 3 functions: g of x, telling me to say is equal to 4, negative x, and x plus that. So we follow the conditions. I'll do the first one, xy. So allow me to put how many? I'll just put 3. It's fine. So the first one is saying x should be greater than or equal to positive 2. Starting from positive 2, 3, 4. So if I put 2, there is no x here. It tells me that any number that I'm going to plug in is going to give me 4. So here is going to be 4. Here is going to be 4, 4. Let's go to the second one. The second one is a bit different. It's telling us where it is starting from and where it is ending. Starting from negative 1, if you have got two numbers starting from negative 1, ending on negative 2. So we're starting from negative 1, then 0, 1, and 2. That's what it tells us. So this is x, this is y. Now since there is x, it means that g of x is equal to negative x. So if I plug in negative 1, it's going to be negative 1 and that, giving me positive 1. So there the answer will be 1. Okay, let's go to the next one. If I plug in 0, 0 is going to be 0. If I plug in 1, here, it's going to be negative 1. If I plug in 2, it will be negative 2. Then when I do this, I'm done with that one. Now I go to the third one. The third one should also be simple. I have x and y. So here I'm going just to get 3. Let's just get 3. So they are saying that x should be less than or equal to negative 1. So negative 1 will be here because I'm starting from there. Then I'll have negative 2, I'll have 2. These are the negative 2, then negative 3. These are the numbers which are less than. So I have got g of x being equal to x plus 2. If I put negative 3, it's going to be negative 3 plus 2, that is negative 1. So here, negative 1. What if when I put negative what? Negative 2. So negative 2 plus 2, I will end up having 0. If I put negative 1 plus 2, I'll end up having 1. I'll end there. Let's now come up with a graph. So here is my graph. Then in x values, the highest number I have 1 all the way to 4. So I'll say 1, 2, 3, 4. 1, 2, 3, 4. In y values, or in negative side of x, I have got negative 1 all the way to negative 3. Neg 1, neg 2, neg 3. Then the y positive value, it ends on what? So I'll say 1, 2, 3, 4. So I'll have 1, 2, 3, 4. Negative side, I have got negative 1. Yeah, there's only negative. Oh, no. Yes, there's only negative 1 and negative 2. So negative 1, negative 2. That's all. So I'm going to start with my first graph that I just plotted here. These coordinates that I have. So we are saying that the condition was x should be greater than or equal to 2. At 2, 4, it is included because it is greater than or equal to. 2 is included. So I'll start 2, 4. Where can I find 2, 4? In x2, in y4 here. So at this point, it's included. Then 3, 4 is there. 4, 4 is there. What does it tell me? The graph is starting from here, going this side. Put an arrow. We don't know where the graph is ending. Don't forget to put an arrow. The next question is telling us that starting from negative 1, but it is this symbol is showing us that it's not included. So at negative 1, 1, negative 1, 1 is not included. I'll put an open. This open tells me to say it is not included at that point. I'll put that. 0 comma 0, where is 0 comma 0? 0 comma 0 is here. Okay, negative 1, 1 comma negative 1 is there. What else can we see? We can also see that we have 2 comma negative 2, which is here. So starting from this point going down, but that point is not included. Don't forget to put an arrow showing that we don't know where the graph is ending. The next one, I'll start with negative 1 comma 1. But since these things are not included, in fact, let's do this. This one is telling us where to end. We have ended on what? The one in between. So this one is telling us that x is less than 2. And so at that point, I'm not supposed to put an arrow because I know where it is ending. Where it is ending again is less than. So at that point, I need to put an open as well, because it is ending there. It is telling me that x is greater than -1 and x is less than 2. So it is telling me where to start from and where to end. Okay? Then, if I do that, I can now go to what? To the second one. So this second one, if I can clearly see here what I have. Okay? I'm going to have -3. I can start with -1 comma 1. -1 comma 1, it is included at that point. Don't forget. It is included at that point. So what does it mean? It means that -1 comma 1, -1 comma 1 is here, meaning inside here it is included. So I'm going to put a dotted line inside. Closed one. -2 comma 0. -2 comma 0 is going to be here. What else do we know? We also have -3 comma 1, which is here. So now this is telling me that starting from this point inside there, going this side. Now this one, it was just telling us that x is less than or equal to -1. So I'm going to put an R because I don't know where this graph ends. The difference between the first one and this one is that if I go back and check this, this is telling me -1 is less than x less than 2. It's telling me that x is greater than what? -1, but x should be less than what? 2. So I know where to end. I'm ending on 2, but 2 is not included. But starting from -1 not included. That's why I have put the end point here open, even this one open. Okay? So try to explore different type of questions based on the same piecewise function, and I believe you'll be able to solve. Okay? So let's talk about even and odd function. So how do you know that a certain function is even or a certain function is odd, or neither? So for you to conclude that a function is even, then f of -x should be equal to f of x. If I plug in -x in the function should come as the original, the way the original function is. Then this function is even. If f of -x gives me -f of x, then this function is odd. If these two guys are not attained, then the function is considered as neither. Neither even nor odd. Okay? Let me give you a brief example about this function. Okay? So let's say we have f of x being equal to x squared minus 4. Is this function odd or even? Let's see. So now the first thing to write, or the first thing to do when you are talking about even and odd function, is to say, this is the first thing you're going to do in any type of question like this for even and odd function. You say, before you even start solving, you say, for a function to be said as or to be said to be even, f of negative x should be equal to f of x, and odd, f of negative x should be equal to negative f of x. This is the initial statement. Okay, so you have to write this. So sometimes this is just a different English. You can use your own English. For a function to be considered as even, f of x should be equal to f of negative x should be equal to f of x, and for a function to be considered as odd function, f of negative x should be equal to negative f of x. This is the first statement that you have to write before you solve any question for even and odd function. Okay, now after writing this statement, you can now start solving. You have already told the person who is going to mark your paper to say, I'm going to conclude based on the statement that I've given you. So everyone who is going to be marking your paper, they will be referring to the initial statement that you have given them. Okay, so other people can write this statement. It's not that everyone can write the same thing, no, but you can also say, but this one is going to be neat. For a function to be considered as even function, f of negative x should be equal to negative f of negative x should be equal to f of x. And for a function to be considered, you continue again, and for a function to be considered as odd, f of negative x should be equal to negative f of x. Simple. Now from this information, I can now start solving. So these questions I'm going just to be solving, but mind you, this statement should be the first thing before you start solving any kind of question for even and odd. Okay, let's begin our discussion with the first question that we have been given. So I'll say, for any kind I'm going to be plugging in, so in this function where there's x, I'm going to plug in negative x. Now this negative x to a power 3, then negative x raised to a power 4 plus 1. So f of negative this, let's see, it's going to give me what? Okay, it's going to give me negative x to a power 3. This is going to be negative x to a power 4 is x to a power 4 plus 1. When you reach at this point, factor out negative. Okay, the reason why I'm factoring out negative is because we are saying I need to have either this or this. So I'm going to factor out negative. Why am I going to factor out negative? Because I can clearly see that this is not the same as the original function. Original function x to the power 3 doesn't have negative. So if I have seen that it's not the same, I know that it's not even. If it's not even, let me try to factor out negative. If at all, the ones in the brackets is going to be the same as the origin. Cool, right? Now, if I factor out negative, I'll have x to the power 3, down here x to the power 4 plus 1. Let us see. I've got negative outside. Let us see what is in the brackets. Is it the same as what is there, the original? Yes. So now I can clearly see that f of negative x is equal to negative f of x. You see now, right? So that's why I say the first statement is important. Then I'll say, therefore, f of negative x is equal to negative f of x. Then I say the function is odd. There is no debate about it, guys. Something that is not complicated. It's simple as that. So try to check, is it the same as the original? No. If you have got a negative, factor out negative. Is it going to come out as f of negative x is equal to negative f of x? If yes, that is odd. If that doesn't fit as well, then that is neither. Okay, let's now jump into the second one. So I'm going to give you some other questions for you to solve. You get my point, right? For you to do it. So let's now dive into part 2. So g of x is equal to x to the power 4 divided by x to the power 3 plus 1. They have just switched for the first question, meaning that g of negative x, remember here we are now following this. I was giving you f of negative x. If the function is g, I'm going to use g. So this is going to be equal to negative x raised to the power 4, here negative x raised to the power 3 plus 1. G of negative x is equal to negative x to the power 4 is x. This is going to give me negative x to the power 3 plus 1. Let's see. The first thing that I have to consider now is it giving me is it giving me the original function? No. At this point, g of negative is g of negative x giving me g of x? No, because there's a negative here. Here there is no negative. Then this is not an even function. So if it is not an even function, what should we do? What if I factor out negative? Do you think it's going to give me the ones in the brackets are going to be the same? Let's see. If I factor out negative, meaning this is going to be negative x to the power, this should be to the power 4, negative x to the power 4, down here is going to be what? It's going to be x. Okay? In short, if I factor out x on top there, I can clearly see that just on top there, in short, on top there is no negative. So there's no need of me factoring negative. I'm just wasting my time. Let me not waste time here. I'm just wasting my time because on top there is no x. I can only factor out x if it is on the numerator. So there is no x, I can't factor out. So if that's the case, I can conclude that this is not even. At the same time, this is not odd, then this is neither. Neither odd or neither even nor odd. Okay? So that's how we now do these questions, guys. They're not complicated, as you can see. So what if we dive into the second one? Let's see. F of negative x, don't forget to write the first statement. I'll put here negative x minus 1 over negative x squared. F of negative x, anything in the modulus comes out as positive. That's what we should remember. So that will still be negative. This negative will go because it's a modulus. So negative x squared is x squared. This is exactly as the original function. What is our conclusion? F of negative x is equal to f of x. Therefore, the function is even. If I didn't have the modulus there, this function would have not been even. Let's try if at all we didn't have the modulus. Now I'm solving this question if at all we didn't have modulus. So it would have been like this. Then there is negative in front here. Let's factor out negative. If I factor out negative, it will be x plus 1 over this. Quite okay, there is negative, but the ones in the brackets, are they giving us the original function? No, because here there is negative, but here there is positive. It would have been neither. Okay, but because there is modulus, that's why we have considered as what? Even function. Let's do part 4. F of negative x is going to be equal to negative. So what I'm going to do for this question, to make things simple for us, okay, to make things simple for us, I'm going to do this. I'm going to do this. So I'm going to plug in negative x minus 1 to the power 3. Now, one thing I want you to understand is that as long as it is raised to the power 3, it's going to be x raised to the power negative 3. So if x raised to the power negative 3, still it will be negative. So that's why I know that this will still be negative. Then this will still be also what? Negative, like that. Then what should I do now when I do that? What I can do is, what if I factor out negative? But how can we factor out negative there? Let's see. If I factor out negative, what I mean by factoring out negative is this negative that is in front here, I can factor out direct. It's possible. Or what do I mean? This is the same as negative 1. So negative 1 raised to the power 3, it is negative 1. So this can be written as, I want to use a simple way. I can factor this negative and it can come out like that. I'll put just negative, then x minus 1 raised to the power 3. Even here it will be negative. Then it will be x plus 1. Then this is going to be what? Then this is going to be raised to the power what? To the power 3 as well. But what I mean is, if I factor out, just a minute, I don't want to expand. You can expand if you want. What I mean is expanding this raised to the power 3. But the simple way, I can do is, if I factor out negative here I will remain with x, negative there, it will be plus 1. Then this is raised to the power 3. Here I can factor out negative, then it's going to be x, then negative and positive, it will be negative, like that. Then I raise to power that. That's the simplest way I can do. And then when I do that, I can now factor out the overall negative. So this is now going to be in the brackets, big bracket. Then if I factor out negative there, I expect to have x plus 1 raised to the power 3, then minus, okay, I'm going to have, so even here when I factor out, it will be plus, then this will be x, okay, x minus 1 raised to the power 3, like that. So if I check here, I've factored out negative, but what is inside here? Is it the same as this? I have got this, which is this one. This part is here. And in between here there is plus. And also here I've got plus. So my conclusion will be f of negative x is equal to negative f of x. Therefore the function is odd. So this is just the shortcut that I've used, but if you want you can expand. What do I mean? Expand this and expand that. Plug in the negative x. You see it's still going to give you what? Negative. In most cases, as long as x is raised to the power 3, the function, in most cases, it is odd. X raised to the power 2, the function is even. That's what happens. So let's go to the next question. You can try to solve this one, pause the video, try to work it, and then you compare with the answer that I'm going to find. So f of negative x being equal to negative this squared 1, then negative x to the power 6. X to the power x is going to be equal to, that will still give me x squared divided by 1. Now x raised to the power negative x raised to the power 6. What do we expect? It's like I've got negative x squared times negative x. It's like I have this to the power 2 to the power 2 to the power 2. So this is positive, this is positive, this is positive, and I'll end up having still positive. So still that is going to be positive. So if that's the case, do I have plus or minus? Okay, here there is plus. So if that's the case, then I can clearly see that this is the same as the original function. So x to the power this is equal to f of x. Therefore, the function is even. We go to the last one. We see what's happening. F of negative x is equal to, I plug in here, negative x, then here also negative. Anything in the modulus, like we said, it comes out as positive. I'll still have the modulus of x, positive x. This one will still be negative. The way this question is, even if I factor out negative, I'm not going to get the original one. Let's see. If I divide negative in this case, let's try to factor out negative. Or if I divide negative, f of x will be equal to negative the modulus of x divided by x. So if we clearly see here, so f of negative x, I factor out negative the modulus of x divided by x. What is in the inside the brackets is basically the same as that, and I've got minus outside. So then this is what f of negative x is equal to negative f of x. The function is odd. Try to explore different type of questions and even and odd, and try to see if at all you can manage to solve by yourself. So this is what I wanted you to understand when you're talking about even and odd function. So let us talk about the domain of a radical function and a rational function. So I have the first question here, that is a radical function. So a radical function is a function that is in the square root. And one thing I want you guys to understand is that whenever we're talking about radical function, we should understand that we can never have the square root of a negative number. So if you have got the square root of a negative number, that is undefined. Okay? So if it is undefined, to make things defined, the only thing that we can have in the square root is starting from 0 going to positive infinity. Okay? I can have the square root of 0 is 0. 1, 1. So as long as I've got 0 going to positive infinity, that is okay in the square root. So what conclusion can I make? I can say that everything that I'm going to have in the square root, I equate them greater than or equal to 0. Then I solve for x. That's the domain. So for any domain, for any kind of a radical function, and we are trying to find the domain, so you just get what is in the square root, x minus 3 greater than or equal to 0. Why are we equating to greater than or equal to 0? Because we know that the only thing we can have in the square root is c starting from 0 going to positive infinity. At this point I can solve for x. X will be greater than or equal to 3. Meaning that the domain, since we are saying that greater than or equal to, we are including that number. So 3, starting from 3 included all the way to positive infinity. That's my domain. I can also put my answer in set builder notation, where I can say the domain x is such that, or you can say x is such that x is greater than or equal to 3, comma, x is a member of all real numbers. Other people will tell you to say set builder notation can be represented as x is a member of all real numbers such that x is greater than what? Is greater than or equal to negative 3. Oh, is positive 3, sorry. Positive 3. Okay? So, you can also say that is the way it is. So, one thing I want you guys to understand is that whenever we're talking about the radical function, We can never have a square root. We can never have a negative in the square root. If we have such case, then that is undefined, unless if I go back to now complex numbers, where I'm going to say I can find the imaginary number. Okay, now let us go to part 2. You can clearly see that part 2 is basically the same as the question we're from solving. I'll just get what is in the square root. Okay, I'll get what is in the square root. What do we have in the square root? In the square root we have 3 minus x greater than or equal to 0. Solve for x. This is the same as if I shift 3 to the other side, I'll have negative x greater than or equal to negative 3. But I can't have negative here. I need to divide both sides by negative 1. Even here negative 1. The moment you divide it by negative, this changes. If it is greater than or equal to, it will be less than or equal to 3. What does it tell us? The domain is starting from negative infinity all the way to 3, but 3 is included. Or you can say domain x is such that x is less than or equal to 3, but x should be a member of all real numbers. So that's how we write the domain. Okay, so we are interested in the number of the values of x that can fit, that can make the function defined. Okay, now I'll first go to part T. I'll jump. I'm not going to do this one first. I'll first solve this one, then I'll come back to that one. Okay, so now I want you to understand that whenever we're talking about it, there's what we call the square root, the fifth root, and the fourth root. So these two guys are basically the same. What happens here is the same as what happens there is basically the same as what's going to happen where? What's going to happen where there's 4 there? Okay, that's what we need to know. But now I want to show you something. So in that case, I'm going to say 1 minus x is greater than or equal to 0. So negative x greater than or equal to negative 1. Divide both sides by negative, x will be less than or equal to 1. Meaning that the domain is from negative infinity all the way to 1. 1 is included. Okay, that is the answer for that question. But in a case where we have got a cube, let's say we have the cube root. Now I'm just making this question in a case where you come across such questions. Now what it means there is that if I have this, let's just put x, I can have any number here. The cube root of any negative number is still undefined. For example, the cube root of 8, or let me tell you, the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2, it gives me negative 8. That is what I have there. So if at all I have got a cube root, so this is the fourth root. We have a square root, cube root, and fourth root. So now, as long as there is 3 here, you should know that the domain, any number can fit. So the domain in that case, it will be from negative infinity to positive infinity. In that case. Okay? So I'm just giving you a hint here. Now that we have talked about the radical function, let me jump. I go to part 5 so that I explain about rational function, then I'll come back and solve this one. Okay, so f of x is equal to 1 over, although the modulus is not going to affect anything, one thing we should know about rational function is that f of x can never be a number over 0 or 0 over 0. This is also undefined. Doesn't exist. Now to make this function defined, we have to make manipulation. We have to make something. Okay, so what I'm going to do is I have to get what is on the denominator the way it is, x minus plus 1. It should not be equal to 0. The denominator should never be equal to 0. So for x, okay, x not equal to neg 1. What does it mean? Meaning that the domain is from negative, all the numbers can fit except negative 1. That's what we need to understand there. So all the numbers can fit except negative 1, meaning I can start from negative infinity all the way to negative 1. Negative 1 is not included, union, again starting from negative 1 to positive infinity. So all the numbers except negative 1. That's why where there's negative 1, I have put this, meaning this number is not included. Okay? So that's the domain. So for any rational function, you have to get the denominator, set it not equal to 0. Solve for x. Okay? But there are some cases where, let's say you have been given f of x being equal to 1 over x squared minus 4. Just get what is on the denominator. X squared minus 4 should never be equal to 0. X squared should never be equal to 4. You get the square root. X should never be equal to plus or minus the square root of 4. Then x should never be equal to plus or minus 2. Meaning that the domain will be from negative infinity to negative 2. Negative 2 should not be part of it. What I mean there, I've got x is equal to negative 2 and x is equal to positive 2. So union, again starting from negative 2 all the way to 2, but these are not included. Union, again starting from 2 all the way to positive infinity. So the 2 and negative 2, they are not part of it. Okay? I'm going to give you a question. Try to find the domain, and I'll be waiting for the answers in the comment section. So find the domain of f of x being equal to x minus 1, then x to the power, let me just say x plus 4. And also find the domain of 7 divided by x to the power 2 minus 16. So find the domain of this. So I'm waiting the answer in the comment section. Okay. Now, so for you not to confuse the way you are going to report these answers, let's get that this is 10 and this is 11. So when you are reporting, when you are typing the answer in the comment section, report this one as question 6 10 and question 6 11. Okay, so let's now see. So now another thing that we have to take note here is we are now going to, this is the combination of rational function and radical function. Quite okay, we know that on the denominator we can never have 0, but there is a square root. In the square root I can have 0. That is okay. Okay, so one thing I want you to understand is that the denominator should never be equal to 0, but again in the square root we are saying it should be greater than or equal to 0. So if there is a number and the square root is on the denominator, okay, the square root is on the denominator, what we normally do here is to satisfy this function, just get what is in the square root, equate equal greater than what? 0. Why am I equating greater than 0? So that the square root and the denominator should make the function defined. If I put greater than or equal to, meaning I'm including 0. Since the square root of x minus 3 is on the denominator, if I include 0, that is wrong. I can never have 0 on the denominator, so that can't fit. But if I put not equal to 0, again that is not true, because in the square root I can have 0. So then greater than only can fit, can suit both. Okay, so greater than 0, I can have a number greater than 0 on the denominator. That is cool. Again, I can have a number greater than what? 0 in the square root. That is cool. So greater than fits for both the rational and the radical. So that's why I'm going to use the greater than. So for this one, I'll say x is greater than what? 3. Then any number can fit here, so it will be from 3 not included, because it's greater than 3 all the way to positive infinity. That's the domain. So any number that I can put there, as long as that number is greater than 0, then I'm okay with it. So starting from 3, but 3 is not part of it. The moment I include the 3, if I do 3 minus 3 is 0, the square root of 0 quite okay is 0, meaning I've got 1 over 0, which is undefined. That's why I have put this open interval to show that 3 is not part of the solution. Okay, so that's how you find the domain. Now here I'm going to jump again, go to this. So in that case, we are only interested with what? The denominator, because on top there is just a linear. It's a linear function. So the denominator, it will be x greater than what? 0. It's the same as the one I'm from solving here. So starting from 0 all the way to positive infinity, that's my domain. Okay. Now let us solve this one. This question. On top there is the square root in this case is not on the denominator. So if that's the case, one thing we should remember, guys, that if that's the case, then for the top part only to be defined, the top part, forget about the denominator for now. I need to get x plus 1 greater than or equal to 0 because it is on the numerator. If it was on the denominator, I would have said not equal. Now in this case, I would have said greater than if the square root was on the denominator. But since it is on top, I'll say greater than or equal to 0. So for x is greater than or equal to negative 1. Let's end here. So we're saying that all the values, x should be greater than or equal to what? To negative 1. But for the denominator, it's not true. Again, denominator, you do it separate. X minus 2, we know that on the denominator, as long as there is no square root, should never be equal to 0. So for x not equal to 2. Now I've got two things. So you have to combine these two. But how can you combine them? Look at what is happening. The numbers of x should start from negative 1 going to positive infinity. But as you are going to positive infinity, excluding positive 2 only, meaning that it tells me that I can start from I'll start from negative 1, which is included, all the way to 2, but 2 should not part of it. Union, again, 2 should not part of it to positive infinity, like that. So this tells me that negative 1 is included all the way to 2, but 2 should never be included because x should never be equal to 2. Union, starting from 2 all the way to positive infinity. So the numerator here has changed everything. If I didn't have the numerator as the square root, the answer would have been from negative infinity to 2, 2 not included, then 2 to positive infinity. But now, because of the square root, if I do that, then on top there is going to be undefined. So I follow that, I follow the second one, I combine. Okay? Now from here we can go to the next question. The next question that I'm going to solve is this one. So this one now, down there, again is a combination. If I had only the square root here, I would have done the way this one, the way we solved that one. But this one is different because there is a number which is not in the square root. In that case, I have to get everything at first equate not equal to 0. So for x, so shift that one to the other side, it will be like this. To solve for x, square both sides. If I square both sides, it will be 1 is equal to x plus 3. Shift 3 to the other side, 1 minus 3 is equal to x, meaning that x is equal to negative 2. X is not equal to, x is not equal to negative 2. What does it mean? On top there, excluding the square root, x should never be equal to negative 2. But again, I've got the square root. I need to consider that. Again, I'm going to solve the square root on its own. So I'll get that should be greater than or equal to 0. So for x greater than or equal to negative 3. So now what is telling us is that any number from -3 going to positive infinity, but we have to exclude -2. That's what it means. Okay, so then I'll say that the domain starting from -3, so -3 is included because it is greater than or equal to, starting from -3 all the way to -2, but -2 should not be part of it, union again -2 not part of it, all the way to positive infinity. This is my domain. Okay, let's do the last one. So the last one here is very simple, but again it is separate. So what are we going to do? This one, okay, there are two ways in which we can solve this. It's either you can say the denominator there, the denominator is x and x plus 2. On top here, x and x will cancel, then you have x plus 2 minus, that one is going to be 3x, of which we are going to have now -2x plus 2 divided by x, open bracket, x plus 2, like that. So you know that this is a rational function. So this function that I have is basically the same as this function. But remember, the denominator should never be equal to 0. So I'll get this not equal to 0. So for x, in this case, x is not equal to 0, comma, x plus 2 should never be equal to 0, then x should never be equal to -2. So I've got two things. All the values can fit except -2 and 0, meaning that the domain starting from -infinity all the way to 0, 0 should not be part of, no, 0 is greater than 2, -2, all the way to -2, -2 not included, union from -2 all the way to 0, but this should not be included, again union from 0 all the way to positive infinity. So these are not included because they are not part of the solution, guys. Okay, so that's basically the domain. So now I have used this method, but again there's a simple way, like you can just get direct, solve this one alone and solve that one alone. It's the same thing. So you can say you solve this one alone, it will be x not equal to 0, comma, you solve again this one alone, x plus 2 not equal to 0, x not equal to -2, and you end up having the same as the ones I solved here. Okay, so now we also have another question asking us to find the domain, but in this case we are going to include the range. Okay, so how do we find the domain of a linear function? As we can see from this question, any value that I can add here is going to make the function defined. So for any linear function, the domain is from all real numbers, from -infinity to positive infinity. That's the domain. But now let us first talk about the range. For a linear function, if at all there is x squared and there is a number without x, it's just direct. So we know that there's a quadratic function is in the form of ax squared plus bx plus c. If a is less than 0, the function is going to have maximum point. If a is greater than 0, the function is going to have minimum point. It's going to curve like that. In this case, a is less than 0 because it has got negative, x squared has got negative. Then we expect our graph to have what? The maximum point. Is that okay? So we expect our graph to have what? The minimum point? Yes, the maximum point. So if the graph has got the maximum point, what we need to understand is that The number that doesn't have x, this only applies, it's going to be different if you come across this question. Let's say you have 4 then plus 2x minus x squared. The method I'm going to teach you right now is different from when you have got such kind of a question. We use a different method as well for that one. So I'm going to use this method only because I don't have a number that has got x only. So then, if that's the case, I'm going to say, if the graph is going to open like this, I know that these things, they'll go all the way to negative infinity in y. The number that doesn't have x is the one that is going to have positive. So in that case, positive 4. The range now can tell you that starting from 4, okay, so starting from 4, that 4 has to be included all the way to negative infinity, but we start with the negative writing. Negative infinity to positive 4. Positive 4 is included. Okay? I think I've made myself clear there. You only do this when we are talking about this type of question. Not when there's a number with just x. No, it's a different one. There's a video that I uploaded recently asking about the range, and it was I explained about such kind of question. In the case where you have this, go back and watch that video on YouTube about how to find the domain and range. Okay, now let's go to the second one. So the second one, remember, we're talking about radical function. So for any kind of radical function, get what is in the square root greater than or equal to 0. So the domain starting from 0 to positive infinity. But the range is going to be different. What I want you to understand is that I'll explain this in this manner. So the range, if I get any value starting from 0 going to positive infinity, okay, I'll start with 0. I'm going just to use two numbers, or let me just use 3. So I can say 1, 2, 3. 1, 2. So now let's plug in the values. If I put 0 there, it's going to be 0. The square root of 0 is 0 times 0 is 0. Then 1 is going to be 1. 1 times the square root of that is going to be what? It's going to be negative 2. Even just here, just 2 lines can tell me what to do. I've started from 0, but again, I'm going negative side. What tells me? What I can see here, the trend is that I'm going down, meaning that y should be less than or equal to 0. Starting from 0, going down. That's what it tells me. Meaning that the range is from negative infinity all the way to 0. 0 should be part of it. If at all I had 0, then I had 1 here, or any positive number after 0, I would have concluded that y is greater than or equal to 0. So only the next number, two numbers, are going to help you to find the range. Another thing that can help you to know that this is the range is because of the negative, which I have here. If this number was positive, then I would have said the range is starting from y is greater than or equal to 0, if that negative 2 was positive. Okay. So now let me go to this one. So this is the question I was talking about. No, it's different. Get what is in the square root greater than or equal to 0. So for x, negative x squared greater than or equal to negative 4. Divide both sides by negative 1, negative 1. X squared greater than or equal to 4. To find the value of x, square both sides plus or minus root 4. So x will be greater than or equal to plus or minus 2. I've got two values. X is greater than or equal to 2, and x is greater than or equal to negative 2. If I want to find the domain and I discover that I've got more than one solution, then this tells me that this is an inequality. And remember, that if I have got 4 minus x squared greater than or equal to 0, it's the same as 2 squared minus this, which is going to be the difference of 2 squares, like this. Of which I know that it's going still to take me to another one is going to be negative, another one is going to be positive. Does that make sense? Yeah. So if I can clearly see that I've got two critical values, if as long as you find more than one solution, so x negative 2 and x 2, then I have to make a table. Negative 2, 2. I'll have 0, 3, negative 3. This means that if I shift this to the other side, it's going to be, or if I shift this to the other side, it's going to be x plus 2. If I shift this to the other side, it will be x minus 2. Then x minus 2 and x plus 2, like that. So if I plug in the values negative 3 into, if I plug in where there is x, it will be negative 3 plus 2, which is negative 1, negative. Here it will be negative overall, positive. 0 here, it will be positive. 0 here, negative, overall negative. What I mean here, 0 here is if I put 0 where there is x, it will be 0 plus 2, which is positive 2. If I put 0 where there is x, it will be 0 minus 2, which is negative 2. Negative times positive is negative. If I put 3 where there is x, it will be 5, positive, 1, positive, overall positive. You look at what we have here. We have greater than or equal to. What does it mean? It means that I get the positive part in this table, but not this. Meaning, I need to get the numbers. The domain will be starting from negative infinity, okay, starting from negative infinity all the way to negative 2, include negative 2, then jump, starting again from negative 2, negative 2 is included, all the way to positive infinity. That's my domain. Now, based on this, how can I find the range? Okay. Based on this, how can I find the range? So now, if you want to find the range in this case, the best way I can show you, even like just sketching, like I said, it's going to be still easy for you. If at all I sketch. Okay. So you can clearly see that. So here, why am I saying that this is the domain? Now, it tells me to say, if I square, I can put any number, including negative 2, from negative infinity all the way to positive 2, but the number should never be from 2 to positive infinity. Is that correct? Let's revisit this. Okay. We divided by negative and we didn't consider negative. This sign was supposed to change. I don't know if you guys have noticed this. The time I was solving, don't you think that this sign was supposed to change? We had 4 minus x squared greater than or equal to 0. We shifted that to the other side. 4. Yeah. So I forgot. Sorry. But I'm going to leave. This is not going to change. The only thing that is going to change is this. So you know how okay, the reason why I've seen that I've made a mistake is looking at my domain. If I put a number that is not in the range of negative 2 to 2, it's going to give me undefined, because let's say I pick negative 3. It's going to be 9. So 4 minus 9 is negative. So then I know that now I've made a mistake. I have to redo it. So like here, shift, it will be negative 4. Divide both sides by negative. Once you divide both sides by negative, this sign changes. Yes, then we now have this plus or minus 2. So now, since this is less than, I have to get the part which is giving me negative and not positive. So you follow, for finding the domain of a radical function, we follow the last. If it is less than, get negative. Greater than, get positive part. But if I take you back to inequality, original inequality, we follow the original one. Even if here it has changed, we don't care. Take note of that. So meaning that if that's the case, then the domain starting from -2 to 2, both are included. These are the only numbers that can fit there, that can make my function to be defined. If that's the case, it tells me to say, even as I'm going to be finding the range, the x values, I should only put what? When I do this, starting from -2, okay, then I can put -1, 0, 1, 2. These are the only numbers that can fit. These are the only numbers. Now, if I put -2 here, it's going to be +4, 0, so it will be 0. If I put -1, it will be 1 squared 1, so 4 minus 1, square root of 3, which is positive. If I put 0, square root of 4, which is 2. I put 1, again it will be the same, square root of 3. If I put 2, it will be 4. 4 minus 4, 0. So we can clearly see that after adding these two numbers, it starts from 0, it ends on 2. That's what we need to know. Because I can't say it ends on 0. It starts from 0, it ends on 2. Even here starts from 0, ends on 2. So then the range is going to be what? The range is going to start from 0 all the way to what? All the way to 2. So both should be included. From my sketch there. Okay. Now if that's the case, let's do the last one. So try to explore different type of questions based on the same concept. So here we are just dealing with the denominator. The denominator should never be equal to 0. Then x should not be equal to 0. Then we can say from negative infinity all the way to 0, not included union, 0 to positive infinity. That's the domain. How do we find the range? Okay, let's see. How do we find the range? So finding the range is not something that is going to be hard, but we should take note that we can have a negative for x. What do I mean? Let's find the inverse to make things simple. Y will be equal to the modulus of x divided by x. So this is going to be x. It's going to be xy, like that. So we're trying to make x as a subject of formula. What can I do? I can divide both sides by x, but again this is not going to make sense. The best method that I can use is, I do know that the only number that can fit here, x, on the denominator, x should never be equal to 0. That's true. Okay, x should never be equal to 0, but we should take note that if x is greater than 0, then the modulus is going to be positive, so it will be like this. So for that one, I know that we're talking about the range, not the domain. Let me just get rid of this. For this one, if I have got x is greater than 0, meaning that the function is going to be f of x is equal to x divided by x. Why am I doing this? I have done this because I know to say when x is modulus, I can have plus or minus x. So when x is greater than 0, it's going to be positive. In this case, when the numerator and the denominator has got the same degree of x, we divide the coefficient. Then the range will be what? In that case, we'll say y is going to be equal to 0. So we divide that, y is going to be equal to 1. If x is less than 0, then it's going to be negative x over x. Then in that case, it's going to be negative 1. If that's the case, the range, the only values that can fit here to make this function defined is just 1, negative 1, and 1. It's either I can put it in this form, or I can say negative 1 union again 1. But this doesn't make sense because I only have two numbers, so I can put them just in this. So the only number that can fit for y is negative 1 and 1. You realize that if you don't understand this, let me show you a different question, I show you a different method. X, we know that the domain x should never be equal to 0. That's the domain. So the domain is from negative infinity all the way to 0, union 0 all the way to positive infinity. That's the domain. 0 is not included. So I can plug in any number except 0. Let's start with negative 2, negative 1. Jump from 0, go to 1, then go to 2. I'll just use this. If I put p of x is equal to the modulus of x, if I put negative 2 here, it's going to be negative, there is going to be positive 2. The modulus of negative is positive. 2 divided by that is going to be negative 1. If I put negative 1, again it will be negative 1. If I put 1, it will be 1. If I put 2, it will be 2. So any number is going to be just 1, or it's going to be either negative 1 or positive 2. Based on this, then I can conclude that my range is 1, negative 1, 1. That's all. That's the range. Okay.